And welcome all my dear grade 8 elite students to today's video session. In today's video, we are going to be covering for your coming Math Term 3 exam, Learning Objective 6 from Part 1 of the exam coverage, where we are going to analyze figures to identify and use postulates about points, lines and planes. So welcome to the video and make sure you watch it till the end so that you can take maximum benefit from today's session. Let's get started. So in today's video, we are solving questions 5 to 10. Here, if you read the question properly, you have to construct arguments. You have to determine whether each statement is always, sometimes, or never true. So these are the three options. Either it will be always true, either it will be sometimes only true, or it will be false or never true. You have to give your reason, you have to justify your argument. And for solving these questions 5 to 10, we are going to use postulates which are based on points, lines, and planes. So in the next slide, I'm going to show you these postulates and then we will solve each of these questions 5 to 10 one by one using those postulates. So let's first solve question number 5. So this says there is exactly one plane that contains non-collinear points A, B, and C. So let's check the postulate which is giving the solution for this one. So if you read carefully, postulate 12.2, through any three non-collinear points, there is exactly one plane. I will just highlight it for you. So through any three non-collinear points. Non-collinear means they are not lying on the same line. And in this question, you are given non-collinear points A, B, and C. So these are 3 points which are non-collinear. Then there is exactly one plane. This postulate guarantees that. So this is always going to be true. So the solution for this is it is always true because why? The reason is this postulate which says through any three non-collinear points there is exactly one plane, so this is going to be always true. Let's do question 6. There are at least 3 lines through points J and K. Okay, now for this one we are going to use the first postulate. Okay, so if you read this, through any 2 points there is exactly one line. So how many points are given here? There are given 2 points J and K. So from these 2 points J and K, there is exactly one line. But this postulate which is given here says, this statement says there are at least 3 lines. So this is not going to be true because this has to be exactly one line. This is the correct answer. So using this postulate, we can say that question 6, this statement is never true because through any 2 points there is exactly one line. So this is how you say. For question 5 it is always, for question 6 it is never. Let's move to question 7. I will first read the statement. The statement is if points M, N and P lie in the plane X, then they are collinear. So let's see which postulates helps us. So for this one, question number 7, the postulate which is helping us to solve is that the plane contains at least 3 non-collinear points. So this one. A plane contains at least 3 non-collinear points. So when you are given a plane, it will have minimum, at least means minimum, 3 non-collinear points. 3 non-collinear means not lying on the same line. But in this question 7, the 3 points which are given, M and P, all lie in the same plane. And the statement which is saying then they have to be collinear. This is not going to be true because these points have to be non-collinear by this postulate. So the answer for this is going to be sometimes only because the points do not have to be collinear in order to lie in a plane. Let's do question 8. The statement which is given is that points X and Y are in the plane Z. Any point collinear with points X and Y is in plane Z. So let's check this one using the postulate. So the postulate that I'm going to use here is, let me change color. If 2 points lie in a plane, then the entire line containing those points lies in that plane. So if you see question 8, 2 points are given and they are given to be in the same plane, then any point collinear with these points is in plane Z. So this has to be always true, because we are using this postulate that if 2 points lie on the plane, then the entire line containing those will always lie in the plane. So this is very, very true. Next is question 9. The intersection of two planes can be a point. So this is not going to be true, never, because if you see postulate number, the postulate that we are using here is that if two planes intersect, then their intersection is a line. But here the intersection of two planes can be a point is given. It cannot be a point, it always has to be a line. So this is never going to be true because of this postulate. Last one, question 10, point A, B and C. So how many points? 3 points are given, determine a plane. So this is going to be only sometimes true, and the postulate that we are using here is, let me change color. So the postulate here we are using is this one: a plane contains at least 3 non-collinear points. So there has to be a minimum of 3 points which are not lying on the same line for the plane. So these 3 points A, B and C determine a plane. This can only be sometimes true, not always. Brings us to the end of today's session. I hope you found the video useful, and if you did, give it a thumbs up, like, share and subscribe to the channel. Until then, this is Mr. Chika signing off from today's video. See you in my next video. Bye students.